Have you ever heard of Murphy's Law? It's a statement that says if something can go wrong, it will. And there's a corollary. Murphy's second law says that if something can go wrong, it will at the worst possible time. And one of the worst possible things that could happen in our environment is losing our NSX edge, because as a virtual machine, it is subject to the vulnerabilities that happen because of being hosted in ESXi. Fortunately, NSX has its own high availability service that we can use to put up the shields and protect our NSX edge devices, so that if the worst should happen, we can just whistle while we work to fix the underlying problem, because NSX is going to keep on running. So in this nugget, we're going to look at exactly how we protect our edge devices with high availability. So to understand exactly what we're going to be doing with regard to HA, we're going to go ahead and lay out our conceptual topology of how NSX works. And what I want us to focus on right now is the question of where are the VMs? Now, we're not worried about the NSX manager at this point, or the control cluster, which obviously provides redundancy for itself. And we don't need to worry about distributed services because those are distributed across all of the ESXi hosts that are participating in that distribution. So what's left is this guy right here, a logical router control VM, and the edge service gateways that are going to provide the firewall, NAT, load balancing, VPN services. So let's talk about what's going to happen when we enable high availability for NSX. We're going to start off with an initial edge VM that'll be hosted on some ESXi platform. In the NSX manager, we're going to issue the command to enable HA for that particular VM. When HA is enabled, a second VM is going to be deployed on a separate ESXi host. And if we really want to get the benefits of redundancy, we should also ensure that the actual files of this edge VM are stored in a separate data store when we're talking about the original instance of the virtual machine and this new instance that was just created to support high availability. The term for these instances, by the way, is an active node and a standby node. And that refers to the fact that the active node is going to be responsible for 100% of the duties and responsibilities of this edge device, whereas the standby node is performing 0% of those duties. It's just waiting in the wings, looking for an opportunity to be used. Now, whenever there's a new modification to this edge VM, that's going to be something that happens in the NSX manager. And so by virtue of its higher level position, it's easy for those changes to then be distributed to both the active and the standby at the same time. But how does the standby know that it's supposed to kick into gear and become active? How does it recognize a failure? In addition to the normal routing interfaces that are present for an edge device, when we configure HA, we need to choose an internal interface. Not an uplink, but an internal interface to support connection between the active and standby nodes. As an internal link, that could go over a VXLAN, a logical switch, or it could go over a distributed virtual switch. This network is the heartbeat network. So if the standby device does not hear the heartbeat, a simple network pulse from the active edge VM, for 15 seconds, then the standby will declare the active node to be dead. And as such, it knows it needs to kick it into gear and become the active node and take on those responsibilities that router performed. Some services will be able to be performed immediately, like routing and the firewall elements, but other things that require connections, such as load balancing and VPNs, are going to suffer a little bit of downtime. The one thing you might be wondering is, hey, what's going to happen if I fix whatever it is that caused that initial active VM to go down, whether that was a problem at the data store level or at the host level or something in the processing of the VM, whatever it might have been. What happens when I resolve the issue? Well, can we have two active nodes? No way, Jose. So the formerly active node comes online, but is now in the standby state, checking over that heartbeat network to validate that the active node is up and running. And if for some reason that active node should fail for 15 seconds, then it's ready to jump back in and become the active node. This is a single level of protection, NSX HA. And if you're familiar with vSphere HA, we can implement that as well, providing multiple levels of redundancy for our VM. So my friend, this is how we put a shield around our edge virtual machines. And we can do this for every edge virtual machine that we need to protect, both the control VMs for our distributed logical routers and the edge services gateways. However, remember that there is a limit of 2,000 edge devices supported by an NSX manager. And when you apply this redundancy, that really means you effectively only have support for 1,000 because each of those is actually now 2 VMs by virtue of the HA implementation. It's important to understand what to expect out of HA before we implement it, how it's going to fit in as a network component. I hope this has been informative for you, and I'd like to thank you for viewing.